Welcome back everyone to part 3 of the OrCAD Capture tutorial series. My name is Adam Fuchs, I am a product engineer at Cadence Design Systems, and for this video, we're going to actually create some custom parts. Alright, so the first thing we want to do is delete these 3 parts which we added to our library from a third-party provider. Just to put this out there, it is completely okay to create a project exclusively using the third-party provider components. I personally have sort of my own style that I like to use, so that is why I tend to stick to creating parts from scratch, but I will often use a lot of the properties that you can find in the third-party provider libraries, as well as sometimes you can download the part and then just make some small edits to things like the symbol or the footprint even. But for this video, let's go ahead and create the same part, this time from scratch, using the symbols and the footprints provided in the files in the last video. Alright, first thing we're going to do is jump back into Component Explorer. Now, in this IC category, we currently have the CDN Demo 0001 part. This is the MIC 5205 part created in the last video. To add another part, simply right-click on the IC category and select New Component. Now this component, I'm going to stick with the naming scheme for the part number, so this will be CDN-Demo-0002. We're going to keep the libraries in development, and because I right-clicked on the IC category, it's already selected the category as IC for me. And if I wanted to add any subcategories, I could do so here. The part that I want to create in this case is also the MIC 5205, but what I want to make is the 3.3 volt output version. So let's go ahead into the generic name. I'm going to set the value to MIC 5205-3.3. For the class, this is still an IC. Min temp is 40, max temp 125. For the package, we're going to do SOT-23-5. Now this isn't us actually specifying what footprint we're using. It's just so that we have a device package that we can look through in the library when searching for our part. And for the height, I'm going to set that to 1.45 millimeters. So we've set a couple properties. Let's go ahead and assign a schematic symbol as well as a footprint to our part. In the models section, select the paperclip icon and choose symbol. Now, if you correctly added the symbols library, which I provided in the last video, you can select that in the library name. And if you scroll down through here, you should be able to find the MIC 5205 part. Now, as I said, this is a schematic symbol that I already drew to my personal standards. If you want to edit it, feel free. Or if you want to continue, for example, using the symbol that's created by a third-party provider, you can do so as well. Again, it's just a physical representation of a logical part. So to add it, click the checkbox and then select attach, and it's going to attach that schematic footprint to our part. And for the footprint, click on the paperclip icon again, select footprint, and if we scroll down through here, again, all of these footprints should be available to you if you went ahead and unzipped the library that I provided in the previous video. We scroll down, I believe somewhere there is an SOT-23-5 component. Click the checkbox and select attach. Again, it's SOT-23-5. Okay. In this graphics section now, you'll see a preview of both the schematic symbol and the footprint. You can click on them to cycle through, just as a nice preview. We jump back into the properties section. If you want to add any properties to just this version of the part specifically, you can do so. These here are just the properties that come by default with the IC category. Let's go ahead and just add a property called Vout and set that to 3.3 volts. And we can set a description called output voltage. Once we're done, we can click on Save to add the part to our library. And here is our CDN Demo 0002 part. I just noticed that the description is set to integrated circuits. So let's go ahead and do a right click and edit this part and change our description. I'm going to call this MIC 5205-3.3 LDO V out equal to 3.3 volts SOT-23-5. It's just a sample description. If you want, you can copy and paste, for example, from a distributor what they use for their description. Let's go ahead and click save. And now we can place this part in our design. So I'm going to go ahead and do a right click, place, and I can place this anywhere on the schematic. Now, this is a part that we added to the schematic that is without a manufacturing part number right now. If I go back into my Component Explorer, you'll notice that at the bottom here, there's a section for manufacturer part number. If we were to edit a part, this MPN section allows us to add a manufacturing part number, a manufacturer, URL to a datasheet, and things like the ROHS compliance and status of the component. Now, this can be a pretty tedious task. What I'm going to show you is a quicker way to add that information to any of our parts. So for this case, we want to add a manufacturing part number to the MIC 5205-3.3 linear voltage regulator. Let's jump into SimAxis again and search for that part number. Here we'll type in MIC 5205-3.3. So here I see I have MIC 5205-3.3 YM5_TR. Usually these last couple letters and numbers are things like the packaging type or the temperature that the part can withstand. TR in this case, I'm pretty sure means tape and reel. This part, I can do a right click and select link to part, go back into my library, and get a little pop-up here that says to link a part to the database, right click the part in the workspace and choose link MPN. So I'll go ahead and click OK. Go back into my workspace under the IC category, right click, link MPN. And here in the manufacturer part number section, it'll add all that information which we were talking about earlier. Things like the manufacturer part number, the manufacturer, and any additional information as well. Go ahead and click save. Now we can add as many manufacturing part numbers as we want to this part. So for example, if we're creating a resistor, we can have 10, even 20 different manufacturing part numbers for a 10 kilo ohm resistor with 1% tolerance. And that allows us the flexibility of choosing either the cheapest or the most available part when we're ready to export this project. Now, again, when placing this part, we now have two different ways of placing the part. Let me go back to the schematic and delete this. I can either place the part by right-clicking in this section here for the part number, so I can place from the right-click menu, or I can select my manufacturing part number and place this one instead. What this will do is attach that manufacturing part number to this instance of the part that we've placed and make it so that when we go to export the bill of materials using the LiveBOM, we can see all of that manufacturing information for this component in the LiveBOM. We're not going to go too deep into that in this video, but just to give you a preview, let me save this first and launch the LiveBOM. Now in the LiveBOM, we have a lot of information that we can use to tell whether or not our bill of materials is healthy, meaning are we going to be able to purchase and order all of the parts in this project that we've made? Or are some of our parts unavailable? Maybe they're no longer even being produced. Maybe they're not meeting ROHS compliance. Maybe they won't be available a couple months away from now. But in this LiveBOM, if we go into the unique parts, you'll notice that our U1, which is this part that we placed here, has a manufacturer part number of MIC 5205-3.3 YM5-TR that we assign to it, has a manufacturer of Microchip Technology Incorporated. It's within ROHS compliance. It's an active life cycle. And then this LiveBOM actually also grades the part for how available it is, whether or not there is risk to using this part, and actually also gives us a price range as well. So as we go through our project and start adding more parts, we can use this LiveBOM to then inspect our bill of materials and see which parts might be difficult to acquire, and maybe we need to find some replacements before getting too far down the line in the design process. So this LiveBOM is something that we'll always have access to. Just go ahead and close it. As we add more parts into our design, it's a great way to keep track of making sure that all of the parts that we're designing with can be purchased and produced. All right, let's go ahead and create one more part, this time actually from scratch by drawing a schematic symbol rather than using one that's already in our library. I'm going to go back into the Component Explorer. This is another regulator that we want to create, which is a type of IC. Let's go ahead and create a new component. And the component that I want to create, actually the part number that we want to create is the next one in the line here. So CDN-demo-0003. The category is IC. And for the description, let's go ahead and grab that information from the internet. In this case, I'll use DigiKey. So the part that we're trying to create now is the AP3012 DC-DC converter. This is a simple to use boost converter. And let's go ahead and just copy this information directly from the datasheet to use in our description. And then some of this additional information here, let's fill that in really quickly. So the generic name, AP3012, class, this is an IC, minimum temp. Let's see in the datasheet if we can find that information. Let's just set it to, here we go, operating temperature minus 40 to 80 degrees C, 85. The package, I believe this is an SOT23-6. And for the height, again, we can look at the datasheet and see that it's 1.45 millimeters max. For the model, I'm going to assign a footprint from the footprints that are provided. If you want to learn how to create a footprint from scratch, we have plenty of videos like that in our support portal. Or if I find a specific video which I think might be helpful, I will go ahead and include that as well in the links below. So we're going to add the SOT23-6 footprint. And for the schematic symbol, let's just pretend that we don't have a symbol to use for now. I'm going to go ahead and click Save. So we've created our CDN demo 0003 part. This is a DC-DC converter, but it doesn't have a schematic symbol yet. We need to add that schematic symbol. To do so, let's go back into our file manager. And as I mentioned before, if we're looking in our file manager, these are basically a carbon copy of everything that exists in the cloud in our workspace. So if I open up this symbols folder in our file browser, we can see all of these different OLBs that exist in our library. And if you remember back to when we were creating our previous parts, we actually grabbed a schematic symbol from this symbols.olb library here. So let's go ahead and open that up in OrCAD Captured, and we should be able to just add a new schematic symbol pretty much from scratch. I can double click on it. It should automatically open up in OrCAD Capture on the left side here. And here you see are some of the parts that we'll be using later throughout this video series. But what we want to do right now is just add a new part. So I'm going to go ahead and right click, new part. We're going to call this our AP3012. For the part reference prefix, since this is an IC, we can set it to U. And the footprint, we can actually leave this empty because the footprint linking is handled by our Component Explorer. Let's go ahead and press OK. And here we have the schematic symbol creator where we can create a schematic symbol from scratch. All right, now we will use that AP3012 as a reference to create this symbol. I already happen to know that it has 5 pins. So let's go ahead and start by placing a couple pins. In the place menu, go down to pin. You can add a name. I'm going to call this SW. It's pin number 1. And for the shape, I'm going to select short. For the type, let's just keep these all as passive for now. As you get more advanced with OrCAD Capture, you can start using things like the pin type, whether it's a tri-state, open emitter, a power pin, bidirectional, to control some of the error checking in your design. But you can also leave them all just as passive and your schematic will work just fine. For the width, we want this to be a scalar pin, meaning it's not a bus type pin. And then go ahead and press OK and place it somewhere on our outline here. Place it right there. OrCAD Capture will also automatically increment all pin numbers for us. So if I were to place another pin here, it will place it as pin 2, pin 3, pin 4, and pin 5. And then press escape to finish placing pins. Now, I made a mistake earlier in saying that this is an SOT23-6 part. This is actually a SOT23-5 part. We'll fix that in our Component Explorer in a second. But for the schematic model first, let's go ahead and assign all of these pin names correctly based on what we see in the datasheet. So the datasheet has pin 1 as the switch pin, pin 2 is our ground pin. We can either double click on the text and set it to ground, or we can click on a pin and change the name in the pin properties on the right side here. So our pin 3 is the feedback pin. Pin 4 is the shutdown pin. SHDN. Now the shutdown pin actually has inverse logic, meaning that it's active low. To put a bar over this shutdown, what we can use is this special notation with backslashes. So basically after each letter, we're going to place a backslash. And then when we click away, you'll notice that there is now a bar over the shutdown, meaning inverse logic. And finally, our pin 5 is the V-in pin. And we're good to go. So once all of our pins have been named, we can go ahead and click on this outline that you see here and make it just a little larger. This will give us a little more real estate to move our pins around and also to place components between the pins like resistors or capacitors. And one other thing that I like to do is also arrange the pins not in order. So in this case, 1, 2, 3, 4, 5 is in ascending order, rather in their location for how I expect the part to work, sort of. Input voltages on the left and output voltages on the right. So I'll put my V-in pin on the left here. I'll put my feedback pin here. And let's put the ground pin there. to make this just one size larger. Oops. So what we've done is if we expect the input voltage into this chip to come in from the left side, it will connect nicely to the V-in pin as well as the ground reference. The switching pin is on the right side here, and we kind of expect for a boost regulator to have an inductor above the component, and that'll connect nicely here, as well as the feedback pin will be connected to a voltage divider made from resistors somewhere over here. So that just makes it easier to organize the components around this part that we're making. Okay, now one other thing we want to do is also add just a rectangle on this border here so that it's not see-through. This white dotted line is basically saying that this border is see-through right now. So we can go into place, rectangle, and then create a border. Either right-click End Mode or press Escape to finish placing the rectangle. And then if we want to add any additional properties to this symbol, we can do so on the right side here by clicking on this plus. If we want to change the value of any of these properties, we can do so by clicking in the box and just typing in, for example, the value here to AP3012. The reference designator for this part is the part reference prefix. It's set to U right now. I'm just going to center that nicely, or justify it nicely to the corner of this part. If you want to be placing objects and things on the grid or snapping to the grid, you have some grid snap options in the top left here. You can click those, and then you'll have some different behavior on how your pins and rectangles and things like that get moved around and placed. If you want to turn snapping back on, simply click that, and then you should be able to move. In this case, text doesn't follow that behavior, but things like lines and drawing this rectangle will follow that snapping behavior. All right, so our part is pretty much ready to go. We seem to have lost a pin. And I accidentally delete it. Let's make sure that the pin still exists. That might just be a small little graphical glitch. Let's go ahead and save this part and open it back up. AP3012. Yep, it's still there. That was just a small little graphical glitch. So we're pretty much good to go with this part. I'm going to go ahead and save it. And you'll notice that it is in our symbols library. So in this project panel on the left side here, all of our open projects can be cycled through with these tabs at the bottom. So my symbols library project, if I look here, there's my AP3012. Let's go ahead and close this. And now if I'm working in my component browser, as long as the part gets uploaded into our cloud, I should expect to be able to see that part when trying to add the schematic symbol into this CDN demo 0003 part. I'm going to go ahead and right click, edit. First thing I need to edit is I know that I set the footprint wrong. So to do that, I'm going to go into the models, change the footprint. Let's remove, uncheck that box and scroll down to the SOT235 footprint. And then for the symbol, we're going to attach a symbol from our symbols library. There is our AP3012, which we just created. You can click the checkbox and select attach. So since everything is already done, we have our properties, our models, we have a symbol and a footprint, as well as setting a part number, description, etc. We can go ahead and save this part. Let's add a manufacturing part number to it really quick. Again, I'm going to use Semaxis. You can also use UltraLibrarian or SnapEDA if you have a preference. We're going to look for the AP3012 part. And I'm going to do a right click, link to part, go into my IC library, and link the manufacturing part number. And now let's place the part in our schematic. So there's our part, the AP3012. It was created from scratch, while this part over here on the left side, this is the MIC5205. This one we created from the library that I provided to you guys. So that is it for this video. What we've done in this video is created a part from scratch by reusing some of the symbols that were already existing in our libraries, or creating a schematic symbol from scratch by opening up the OLB that exists in our workspace and creating a new symbol for it. In the next video, what we're going to do is really quickly create some additional components like capacitors and resistors, and then we're going to focus on connecting them on our schematic to make a logical design. Again, we have 3 pages in our schematic. We have the power, the micro, and the peripherals, and it should take about 1 or 2 videos just to manage all of the connectivity and create all the parts for those. So look forward to seeing you in the next video. Again, thank you for watching, and if you have any questions or comments, please leave them below and I will try to answer them as quickly as possible. Thanks again. See you in the next video.